Alrighty, everyone. So we're going to be looking at 9.3 today, which is surface area and volume, looking at cylinders. So we've been looking at the surface area and volume of different shapes, and now we're going to be looking at cylinders today. So we know the surface area of a solid is the sum of the areas of all of its outside surfaces. And then the volume is different, and that is the solid amount of space that's occupied by an object. That's everything inside of it. So if we're looking at a cylinder, we're looking at something called a radius, which is a circle, but it's half of the circle. So it's a half of the length of diameter. So diameter would extend from one end to the other, which is our D, but half of that is going to be our radius. So we do know that R equals D over 2 because our radius is half of our diameter. So you can see at the bottom here, there's an image of the net of the cylinder. So it's this drawing to the right, and it's all laid out flat as if we were going to make this shape into a cylinder ourselves. So this top circle right here that we have, this is, if we're going to look at this, we can look at the perimeter of the circle, and that would be our C would be equal to 2 pi r squared. If we're going to be looking at this P part right here, this part right here is going to be our length, RL. This part right here is going to be known as our lateral surface. And then our height is known as our W. So this is all important things that we can take a look at if we were to look at the net of a cylinder all laid out. So the formula for this, if we're going to look at the surfaces, just the surfaces, we're going to look at two circles because we have two circles here and here, plus a rectangle. So if we look at the whole net of that cylinder, that is what our surface is. That's what we're going to be looking at. So therefore, in order to find the total surface area, what we have to do is find the two areas of the circle plus the area of a rectangle. So in order to do that, our formula here is going to be 2 pi r squared. This can also be written in a certain way. The r squared is first, and it could also be seen as 2 pi r squared plus our 2 pi r squared, and then times h. Once again, the r could be in brackets. And we also might see it, because our area of a rectangle is length times width, we can also see it as 2 pi r squared times h. And that's how it could be written. So our formula is going to be looking at two areas of a circle and then the area of a rectangle. So we can see here at the bottom, we have the surface area of a rectangle. This is the formula that we just discussed. And then if we're going to look at the volume, we're going to be looking at pi r squared times height. Okay, because we have to look at the area of the base times height. So these are important formulas to remember. Make sure you understand how to use them, how to identify where to find them, etc. But once again, you will not have to memorize them. It's just going to be important to remember them in order to utilize them. So let's look at an example. So we have to calculate the total surface area and then the volume. So we have to do both of each cylinder and then show our steps. So the first thing we have to look at, let's start off with our surface area. So our surface area formula we know is going to be 2 pi r squared plus 2 pi r h. Okay, so if we go back at the top, we know that that was what the formula was. Now, given this information, we have to plug in all of the values that we do have. So we have our r, which was 3. We have our height, which is 12. So we can just plug those values in. We know what pi is. We know what our r is. And we're just going to solve now. Obviously, we're gonna use our bed mass, so we're gonna get rid of our brackets first. That's what we wanna do. Obviously, we wanna look at our exponents. So what is 3 to the power of 2? That is 9. And then on the other side, we're just gonna keep everything else the same right now, and we'll worry about the brackets in a moment. But let's just make sure we get rid of that exponent first. Now let's look at our entire equation, get rid of these brackets. So 2 pi times 9 is going to give us 56.55, and 2 pi times 3 times 12 is going to give us 226.19. If we add these two values together, we'll get 282.7 centimeters. And because it is surface area, remember it is squared. Do not forget this. Now we look at volume. We know our formula for volume is pi r squared times height. Once again, plugging just our values in. Get rid of our exponent first. And then solve. It's going to be 339.3 centimeters. And then this is going to be cubed because it is looking at volume. Okay. Now I want you to try out number 2 on your own. What is given to you? Remember, this is diameter, so we need to use radius. So radius equals diameter divided by 2, which is going to be 22 divided by 2 is going to be 11 inches. Okay, so now solve. Pause now, try this out. All right, check your work, make sure you got it correct. All right, let's do an example together. So it says here, Nancy made a cylindrical jewelry holder for her dresser. She covered one base and the side with silver paper. If the holder was 12 centimeters tall and 14 centimeters in diameter, how much silver paper did Nancy use? So the first step is always draw an image out. That's usually the best option for yourself, just to make sure you kind of know what is going on, what to expect, what to look for, etc. And you can always label it. So we know that it is 14 centimeters in diameter. Oops, not 14. 14 centimeters in diameter, because that's what it says here. And then it is 12 centimeters tall. Okay, so we know those two things. If we're going to find the radius, it's going to be diameter divided by 2, which is 14 divided by 2, which is going to be 7 centimeters radius. So we need to know how much silver paper did Nancy use. Well, we know based off of this, we're not looking at volume because we're not looking at the contents inside, we're looking at the outside. So we're going to find the surface area of paper, and that is going to be the surface area of the cylinder minus the surface area of the top and the base. Okay, because we just want it on the outside contents, not the top and the bottom. So what we're going to do, we're going to solve for the surface area of the cylinder first, and that is going to be our 2 pi r squared plus 2 pi r h. We know what our radius was. We said it was 7 plus 2 pi 7, and the height was 12. Now solve for it. I'm going to skip a couple steps here. We're just going to solve. We're going to get 835.7 centimeters squared. Now we're going to do, so that's for our cylinder. Now we're going to do for the top base. So surface area of top base is going to be pi r, which is our circle. You know that's a circle. Okay, so pi times 7 is going to give you 153.9. Okay, so now, given these two values, we're going to subtract them now because we need to subtract the 2. So therefore, the surface area of the paper that we need is going to be 835.7 minus 153.9. And that is going to give us 681.8 centimeters squared. Okay, so therefore, that's how much she needs. She needs 681.8 centimeters squared of paper. There we go. All right, try the next example on your own. So we're looking at two different types of soup. Determine, are we trying to find the surface area or the volume? So once we find the surface area or volume, whatever one you decide, then we need to determine the cost. Okay, so we're gonna do our example A here. We're gonna do the first one together and then the other one on your own. So we're gonna start off with surface area. So that is going to be 2 pi r squared plus 2 pi r h. Fill in the values. We know our diameter is 5.5, so 5.5 divided by 2 is going to give you 2.75. 2.75. Oops. And height is 10. So we're going to solve for that. We're going to get 220.5 centimeters squared. Now the next step is to solve for the cost. So it says here the cost of aluminum is 0.04 per centimeter squared. So that means 0.04 times our 220.5 is going to give you $8.82 per can. All right, try that out with the other object. So surface area, so pause now, try it out. All right, surface area is 416.6. Once you now find the cost, so to find the cost for this, it says here the Tetra Pak, which is the other one, is 0.02. 0.02 times 416.6 is going to give you $8.33 per can. So now which pack should they choose? Well, they should choose the Tetra. Because it's cheaper. So that is why we explain it, okay? All right, so there are a bunch of other examples. Try them out on your own. Obviously, the next example could be a little bit confusing, but remember, we're looking at the dryer without the drum, okay? Because the drum is removed, so we need to subtract, okay? So in order to find the volume of the dryer, we need to do, in order to find the volume of the drum, we needed to do the volume of the rectangular prism minus the volume of a cylinder, okay? Because this is a rectangular prism minus the cylinder. So solve for that and you'll be able to find the drum. So continue working on this. It's the same formulas repeated over and over again, either surface area or volume. Our first step is always make sure you determine, are we finding what's inside or we're just looking at what the outside is. If we're just looking at the outside, it's the surface area. If we're looking at the inside, it's the volume. And then from there, use the formula that is given to you. If you have to look at the volume of certain parts of it, you might have to add, you might just subtract. Make sure that you are paying attention to that. If you have any questions, let me know.